Okay, so we have a question about a human cannonball, where they give us a distance of 18.5 meters that the person travels at 1.19 seconds. They asked about this average net force, and average net force is often going to be related to this expression, the average force, right? F equals ma is equal to the mass times the acceleration. Let's make that a little bit nicer. That doesn't look so nice. There. Newton's second law, right? F equals ma. Right? But in this problem, we're not given acceleration, but we are given some information about the kinematics. So we end up using delta x equals v initial times t plus 1/2 a t squared. V initial in this case, since it's a launch, is 0 meters per second because you start at rest. And so when we plug in the distance of 18.5 meters, we end up with 18.5 equals, so it's going to be 0 for the first term, right? We know the time, but since it's multiplied by 0, we don't have to worry about that. And then what we're solving for in this case is the acceleration, because once we know the acceleration, we just multiply that by the mass, and we put 1.19 here and square that. You end up with an acceleration after you go through all the steps of 26.1 meters per second squared. We don't really need any conversions because it was given in meters and seconds. And then once we know that, we can take that and put it into our average force is equal to mass times acceleration average. And that's going to go in here, right? So we multiply out 73.4 kilograms multiplied by our 26.1 meters per second squared, and we get a final answer of 1917.8 newtons. And that is your answer.